So then I went up and I looked up some talks that you'd given, some podcast appearances that you'd had, and you were a 10 out of 10. Just an absolutely amazing communicator.
There's this new need at the center of all that. There's a need to define, how do we actually work with data in this organization? What do all these changes mean for us?
I imagine this idea that if you have this distributed data organization and everybody needs access to data, they're making decisions based on data, those data pipelines need to be up all the time. Barr Moses, welcome to the Super Data Science Show. I'm delighted to have you here. Where in the world are you calling in from?
Thanks, John. It's awesome to be here. I am in San Francisco, California. Sunny today.
Yeah, is that true? We can see in the YouTube version that it's sunny outside, so you've got to be somewhere else.
That's true. All fake news.
It looks like a beautiful day in San Francisco. I guess an unusual day where you might not need a sweater.
That's right. Very unusual for San Francisco, but we'll take what we can. Nice.
I'm absolutely delighted to have you on the show. I had been kind of creeping your internet profile for a while. So you showed up on my radar a number of different ways. I think we've been in each other's LinkedIn network for a while. So kind of just seeing you post things or comment on things, I'd seen you that way. And then Kate Strachnyi, she did a few months ago, she created this LinkedIn post of data voices. And there were a couple dozen people on there and you were on there and I was like, oh, Barr Moses again. And so then I went out, I looked at your LinkedIn profile. I was like, fascinating. I wonder if she's a good speaker. So then I went up and I looked up some talks that you'd given, some podcast appearances that you'd had, and you were a 10 out of 10. Just an absolutely amazing communicator of technical content and just so interesting to hear you speak. So you were on my radar. And then just in one of those serendipitous moments, I don't know what I was doing. I was tweeting about the Super Data Science Show or something. And Scott Herleman of the Data Mesh Learning Network commented on one of my tweets, I guess tweeted at me and said, you should think about having Barr Moses on your show. And I immediately sent you a message in Twitter and asked if you'd like to be. And you said yes. And now here you are.
Amazing. Serendipity. And I'm indebted to both Kate and Scott for being amazing voices in data as well.
Nice. So Scott is from the Data Mesh Learning Network, as I just mentioned. What the heck, Barr, is a data mesh?
Great question. It's $1 million question these days. So let me take a step back and describe a little bit of sort of what I think is causing data mesh to sort of be a hot topic these days. Cool. I think the world obviously the world has changed tremendously in the last year and a half or so, but in the data space, it's really changed a lot in the last 5 to 10 years. I think 5 to 10 years ago, we really liked to say that we were data driven, but it sort of stopped at that. We didn't really go beyond sort of claiming that. I think today when people and companies claim that, it's a little bit more true. It's actually said in earnest, and there's actually more behind that to solidify that. But really, if you think about it, 5 to 10 years ago, very few people were actually doing data science. Very few people in companies were actually using data to make decisions or to power products. It was really a world where, honestly, a lot of data was confined, sometimes in finance, sometimes in IT. There was a handful of very small handful of people who were actually using data to make decisions. And they were using that data not often. So it might be only once a quarter to report to the street. It was based on a limited set of data sources. There was, it was obviously core and was important, but it didn't really have the spotlight. Now, fast forward to today, the world in which we live in is insanely different than where we were 5 to 10 years ago. It's like mind blowing to me. You cannot compare what it's like. First of all, starting with an insane amount of data sources, right? It's not uncommon for companies to use thousands of third-party data sources, right? In the past, maybe you just were relying on like Google and maybe Facebook, and that's about it. Today, there's so many data sources that companies rely on. There's also a lot more complexity in terms of the pipelines that we're building and the architecture, right? So in the past, we had one database and we pulled all the data in that and that's it. Today, you can have several data warehouses, a data lake, ETL, ELT, reverse ETL, BI, machine learning, right? There's so, like, name it, and you have that. So data is really spread everywhere and has become distributed. And then maybe the third sort of big thing that I'm seeing that's happening is the rise of lots of more people that are working with data. So in the past, you really only had maybe a financial analyst or a data entry person, maybe only one or two, sort of a handful of roles that were dealing with data. But today you have machine learning engineers and data scientists and data engineers and analytics engineers and analytics and executives that are using data. Really, anyone in the organization is actually either a producer or a consumer or both for data, which is a tremendous change from where we've been. And so with these sort of three main themes really being the driving force behind everything that's happening in the last decade or so, there's this new need at the center of all that. There's a need to define, how do we actually work with data in this organization? What do all these changes mean for us? Whatever worked before is not going to cut it today anymore. We need to rethink. And so I think that's really what's brought the data mesh to be front and center. So I'll explain the data mesh. So the data mesh is originated based on a concept from software engineering that's been adopted in the data space. So in software engineering, there's a movement that has been, again, in the last couple of decades or so, where we've moved from monolith to microservices architecture. And with that, there's a lot of technologies and processes and people changes that have made in order to support that. Now,
what does that even mean? What's the difference between a monolith and the microservices architecture?
Great question. So fundamentally, it's a difference between managing something in a very centralized fashion versus a decentralized fashion. And so I'll give you a very concrete example when it comes to data. Oftentimes, what we see in organizations that are struggling with a centralized model is where you have a group of people, maybe it'll be called the data platform or the infrastructure team, or can be whatever name, and all requests related to data are coming to that particular team. And so if you want a new report, if you want to use data, if you have a question about, what customers are more important than others, what feature has been most successful to date, what customers are about to churn, any really question that you have about the data and about your business, you have to go through the centralized team. And so think about this team. They have this insane backlog of requests and questions, and they might be like, well, see you in a year from now when we actually have time to get to your request, right? Like, get in line, take a number. And that really doesn't allow for an effective use of data, right? When there's sort of this gatekeeper. And that's when we see companies really ask themselves, okay, there has to be a better way, right? And so what the data mesh sort of at principle is creating a standard sort of centralized best practice or sort of centralized organization that can define standards and norms for what does strong data management actually mean, but then allowing for distributed ownership of data in domain-specific organizations. So allowing for marketing specifically to own data that's related to marketing that has questions about, for campaigns that they're running in particular. Those are very different than the questions that the product team may be asking or that the finance team may be asking. And so the idea of actually breaking down the ability between having the centralized sort of standards and in conjunction with that, the ability to do self-serve and domain-specific ownership actually sort of unblocks that congestion that we had and allows teams to move faster.
Nice.
You may already have heard of Data Science Go, which is the conference run in California by Super Data Science. And you may also have heard of Data Science Go Virtual, the online conference we run several times per year, in order to help the Super Data Science community stay connected throughout the year from wherever you happen to be on this wacky giant rock called planet Earth. We've now started running these virtual events every single month. You can find them at datasciencego.com/connect. They're absolutely free. You can sign up at any time, and then once a month we run an event where you will get to hear from a speaker, engage in a panel discussion, or an industry expert Q&A session. And critically, there are also speed networking sessions where you can meet like-minded data scientists from around the globe. This is a great way to stay up to date with industry trends, hear the latest from amazing speakers, meet peers, exchange details, and stay in touch with the community. So once again, these events run monthly. You can sign up at datasciencego.com/connect. I'd love to connect with you there.
I think I now understand what data meshes are. So historically, we've had these monolithic architectures in software development, including in data-related processes, where you have this central repository of data, probably maybe a bunch of SQL databases or something that only the data science team or the data analytics team really has access to querying. But we're moving more and more to this distributed scenario where, as you've mentioned, with lots of people across organizations needing access to data in real time and being able to do at least some simple data pulls, but maybe even some complex modeling. You could have people on your marketing team or on your HR team who specialize in getting these data out and actually doing some sophisticated modeling. It doesn't need to happen on some central data science team. So with a data mesh, you still need, it sounds like you still want to have across the company, not a central team or the central dependency, but you want to have a centrally defined standard. Right, okay. But then anybody in the organization can plug in, can, I guess, create data, store data, and access data from this data standard.
Yeah, I think the idea is that right now it's a little bit of a wild west, and so to create some sort of, I think what we're seeing is definitely sort of the creation of this standard and norms, and that's typically sort of federated by sort of a centralized group. And then there's domain-specific owners for each of those areas that you mentioned. And to your point, you're absolutely right. Like, you could actually have pretty sophisticated models in other areas, such as marketing and HR, that are not in the sort of standard centralized data organization. Now you might ask yourself, like, what are some of the challenges with implementing something like this? Probably the biggest challenge that we actually see is sort of a change management challenge, actually. So figuring out, how do you structure the team? Who should be on which team? Who should own what? What is mandated, if you will, as sort of a standard, and what is not? What are some of the technologies that you use, in a central fashion, and what do you actually enable to the domain-specific owners? That's probably the biggest question, or sort of the biggest sort of challenge that we see folks run into. And the first thing within that, and the first sort of kind of friction that comes up is in this model, you are actually allowing different groups of people to own specific parts of the data. But in doing so, you also need to make sure that they can answer some fundamental questions about the data. Like, for example, which data should I be using? Which table is the right table to use? When was this table actually updated? Is it fresh? Can I actually use this? What does this data mean? Who's using this data? Has this data been used in the past or not? And so actually allowing folks to have access to data, but not letting them be able to self-serve on those questions poses a really big challenge. And so that's kind of how we think about self-serve data reliability to enable the implementation of the data mesh.
Okay. So you just used a term that I really want to dig into there. You said self-serve data reliability. So it's clear that is a critical concept to having a data mesh work. Can you tell us a bit more about that?
Yeah, I just threw a lot of buzzwords at you. So let me unpack that a little bit. Data reliability is a concept that, again, draws on a concept from software engineering. So in software engineering and DevOps in particular, there's a concept of making sure that your applications and your infrastructure are reliable, which today seems like a no-brainer, right? Like, of course. Exactly. right? Like something that's like super obvious to us, right? But 10 years ago, not as much. Today, it does seem a little bit crazy to have a software engineering team that doesn't think about reliability, doesn't have something like, Datadog or Grafana, or really any solution to actually like monitor the reliability and the uptime of infrastructure and applications, right?
Totally.
And that, is really emerged in a very important part of our ability to deliver software solutions or products that are scalable and reliable and secure.
Got it. So just to say something back to you to make sure that I understand this. So data reliability is basically, it's analogous to a software service uptime. So in the same way that if you have a website, if you run facebook.com, you need to have Facebook up all of the time. And so you have all these tools in place, like you mentioned Datadog, in place to make sure that you have redundancy. And if one thing goes down, something else can come up and your site is still up. So it sounds like data reliability is, I imagine, this idea that if you have this distributed data organization and everybody needs access to data, they're making decisions based on data, those data pipelines need to be up all the time. Is that the idea?
Yeah, that's exactly right. The stakes are higher now. You cannot have data downtime anymore. In the past, when less people were using data, there was less data going around, and it wasn't as mission critical. Like it wasn't actually like products weren't really relying on it. In that world, it was fine that data was down and no one noticed. And it was fine that data was wrong, every once in a while. And on top of that,
the data needs to be right too.
Exactly.
Yeah.
So data has to be right. And I'll add another complication to that. In the past, it was really or relatively easy to manually make sure that it was right. I could just stare at the numbers for a long enough time and look at where the data came from, and I could tell you whether it's accurate or not. So, if I'm looking at our revenue numbers or the number of visitors on our website, I should have a pretty strong understanding of that because I'm only looking at a small handful of metrics and I'm looking at them regularly. And, I report on them once a quarter. So I have a lot of time to think about whether that number is right.
This one cell in this spreadsheet is wrong.
Exactly. When you get like a model from someone, you're like, I don't understand anything from all of these formulas. I'm going to go one by one and check it. Maybe you could do that manually once, right?
Yeah.
Terrible, right?
There's too, like you're saying, there's too many data sources there, and they're coming from, some of them are coming from third-party vendors, some of them are coming from other people in the organization. And so you can't, in a modern organization, increasingly, you can't possibly keep an eye on every single data source manually. I totally see the need here.
It's sort of mind-blowing, right? That we've come such a long way. And so, the question is, we sort of, as an analogy, sort of call this kind of like data downtime. How do you minimize data downtime in an organization in order to increase trust in the data? So we actually see organizations start measuring things like time to detection of data incidents. How quickly did you identify that your data was wrong? Oftentimes we see companies go from months to minutes in time to detection, which is huge when that data is actually, like, I'll give you an example. Let's say it's a data set that your marketing team is running a campaign for in Facebook. Let's just use that example. If you're targeting the wrong people and you find out about that months later, that's a big deal. Your company's lost a lot of money. If you are using data to price something, let's say you're selling a marketplace, let's say you're selling homes or selling jeans or selling shoes. If you're underpricing or overpricing for a long period of time, you're losing a lot of money. And not knowing about that can be disastrous. And the reality is that's happening today already because we've already opened the floodgates, let everyone use data. But now we're like, oh, wait, but maybe sometimes the data is wrong. We need to make sure that's actually accurate.
Nice. So somehow, I suspect, based on things I've read about you and your company online, that your company, Monte Carlo, can somehow help with all of these data uptime challenges?
Yeah, I mean, we're really sort of focused on helping kind of the community sort of figure out. So what do we, okay, maybe the question is, how do we actually solve data reliability, right? Or what's the right way to approach that? And so with the thinking that it's sort of the first step to actually being able to use data in your company. And so I think the solution, again, draws on what we've seen in software engineering. And I like to mention that because I think there's something really nice about the fact that we don't have to completely reinvent the wheel in a sense. And by the way, the problem of data being wrong and data quality has been around for decades, right? It's sort of the old age problem in data. Nothing is new there, right? But all of these changes actually introduce an ability to solve this problem in a totally new way that hasn't been that was not possible until today. And that is, the standardization of cloud solutions, the rise of solutions like Snowflake and Databricks and GCP and Looker and Tableau and so many others that are really sort of allowing data teams to get faster and better in how they're using data and how they're processing data. And so the question is, how do we make sure that the data that's running in all of those systems is actually accurate? And the solution is, again, as I mentioned, is sort of a concept from software engineering. How do you actually solve that in software engineering? Well, what you do is you look at certain metrics, or you look at the outcome of the system to understand the health of it, right? So you sort of call this observability, right? Meaning trying to understand what are some indicators of a system that can tell us whether it's healthy or not? So we actually call this the good pipelines, bad data problem. What do I mean by that? I mean, you've invested so much in setting up the best data warehouse, the best data lake, the best pipeline. You have real-time data, the best machine learning models. Everything is, top notch, but the data that's powering all of that is actually inaccurate.
Right.
And so one of the ideas is that in order to solve that, what if we looked at specific metrics that helped us understand whether the data is accurate or not? And so we actually spoke to hundreds of data organizations and asked them, how do you solve this problem? How do you solve the good pipelines, bad data problem? What do you do? What do you look at in order to understand whether data is accurate or not? And based on that, we actually took all that good stuff and consolidate that into sort of 5 core pillars of data observability. Those are freshness, volume, schema, distribution, and lineage. And we believe that if you can automatically collect information, monitor those 5 pillars, you can actually have a holistic, unified view of the health of your data. And so to really define kind of like top-notch, best-in-class data reliability means having some way to really define what those 5 pillars are for your organization.
Cool. That makes a lot of sense to me. Can you reel off those 5 pillars to me one more time?
Yeah, of course. The first pillar is freshness, which is related to everything about the timeliness of your data. Has the data arrived on time? Maybe you expect it to be, at 6 a.m. and it arrived at 6:50, and maybe that's a big problem because someone downstream is using it at 6:15. You need to know about that. The second pillar is volume. So, number of rows is a sort of good basic example. Maybe you've been getting 20 rows every day, and suddenly you're getting 20 million rows. That probably indicates something is wrong. The third is distribution. And distribution really speaks to the values themselves. So it could be anywhere like percentage null values, or if you have a particular field that, you typically track credit card numbers and suddenly you have letters there, probably something is wrong. The fourth is schema. So schema changes, sort of around the structure of data. If a table is added, removed, if a field has changed, field type has changed. And then the fifth is lineage. So lineage, when I say lineage, I actually mean lineage at the data level, not at the job level. So at table level or field level lineage, and overlaying that along with the ability to say something broke here in this table, and here are all the dependencies on that. Here are all the reports that are being used. And by the way, they're being used by your marketing team for that campaign daily. You better fix that problem that you have in this table. maybe there's another table that has a big problem and there's nothing downstream that relies on it. So who cares? That's not a real problem.
Cool. Well, not only did you reel them off for me, but you gave me illustrative, clear examples. So that was beautiful. I'm sure the audience appreciates that. So it sounds like if we're going to have great data reliability, we're going to have a data mesh. It sounds like philosophically, we might have to make a lot of changes to our organization to make the most of that. So how do we build a data team or an organization to handle this new world?
Such a great question. The most common problem that we see is actually this finger pointing or blame game, where every team is really sort of blaming a team either upstream or downstream of them for the data problems. So, some of the issues that we do see, I'll give you an example. Let's say there's sort of software, there's like an engineering team. There's a data engineering team there's an engineering team that's sort of responsible for, specific product. And then there is a data engineering team that's building the pipelines to ingest that data and transform the data from that. And then there is a data analyst or data analytics team that's in, creating specific reports that, say, marketing and HR team is using. We oftentimes see, in this simplified view, analyst team sort of pinging the data engineering team and saying, why is the data wrong? Why is it coming late? What's going on? And then the data engineering team will be pinging the engineering team saying, what's going on? Why is the data late? We can't figure out the root cause of this. And then there's weird sort of dynamics and friction. And then the other way around can happen. The engineering team can say something like, the jobs all ran perfectly well. Everything is fine. We don't know what the problem is, right? And so there's this dynamic where it's actually really hard to untangle things. And so when you think about sort of team dynamics, the first sort of, or one of there's a few sort of tools that I think are really helpful to facilitate that. And one is to actually think about SLAs and SLOs regarding your data, which are essentially ways.
All right. So we got SLAs, SLOs. What are those, Barr?
Service level agreements and service level operations.
Got it.
And basically the idea is there are contracts that allow teams to set expectations around, let's take freshness as an example, around when do I expect sort of data to come in, right? At what time? And what percentage of the time should that be happening? So it's sort of the common, sort of notion of having 5 nines of availability in software engineering, right? Basically the equivalent of that in data.
So the 5 nines being 99.999% uptime. And then I just want to quickly talk about that word contract. So you talk about having these service level contracts to say guarantee some level of freshness of the data. This doesn't mean that someone on the software engineering team literally signs a contract for the data science team, which is how I typically think about contracts. But it's an agreement internally, not literally a signed document, but just this idea that I agree that our team's going to do this. We'll provide you this data with this level of freshness, and then so you can build your processes based on that.
Yes, it's a badge of honor that you're doing this, but but actually, it is also helpful to document that, right? So while you might not be signing your name, if you do, there are solutions to, and Monte Carlo is one of them. To actually document these and to help automate when they don't happen so that you can actually enforce those. If that makes sense.
Makes perfect sense. Yep.
And then the other thing on team organization that we see that's, I think, pretty cool is sort of the rise of new and important roles. So for example, the role of the data product manager. So the thinking of the product manager that's actually dedicated to, thinking of how to build data products. And that's a pretty new concept as well, thinking of data as a product.
Yeah, that's a new one to me. And it makes perfect sense. Now I know exactly what you mean, and I can see the value of it, but I've never heard somebody put those 3 words together before. Cool. Data project managers. Wait, project manager or product manager?
Product. Data as a product.
Data product manager. Yeah. Glad I asked. And yeah, that's the one that makes even more sense. You could imagine a data project manager, but data product manager Yes. Yes.
We can add another one if you want, John.
I could see more demand for this data product manager. Nice. Okay, so we've understood now about data meshes. We've understood about data reliability. We know about the challenges in building data meshes, including these kind of philosophical ideas around how to build a data team and having specialized roles like data project managers involved. So very interesting, and loving understanding how Monte Carlo fits in with all of that. So I'd love to ask you now some questions that have actually come from audience members about your, about your background, about your company, and they tie in to everything that we've already covered. So the first one is from Ciro Gomez Parsian, who is a Microsoft Analytics and Cloud architect at ViewNext. And Ciro is curious about how your intelligence background has influenced your career since. So listeners probably don't know, but you have a storied career, both in the private world, in technology, and in consulting as well. But prior to that, you started in the Israeli Air Force as a commander, and you were involved in, even back then, analyzing intelligence data. So it sounds like, it sounds to me like there's kind of this arc. There's been this analysis and quantities and mathematics and computer science, I guess, throughout most of your life. But I don't know why I'm saying all this. Why don't you just fill it in for us?
Way better when you say it. So I was born and raised in Israel, actually in the Weizmann Institute of Science. So my dad is a professor of physics. So I spent a lot of time in his lab, trying to blow up things. My mom is a meditation teacher. So I also spent a lot of time meditating, maybe not as much as I should have.
That's probably always true. I think everyone always feels like that.
Exactly. Eat your veggies and meditate is what I should be doing. So in Israel was drafted to the Israeli Air Force. I was a commander of a data unit. Spent a long time doing data analysis. Obviously, very very different than what we're doing today. Right, this was a long time ago, and different technologies, and honestly, also very different use case. Maybe there's certainly a lot of learnings from that time that have influenced my work today. I think sort of being at that young age, working on such sensitive material, you develop sort of a responsibility and a strong understanding of sort of how important, data is actually to just some decisions that can actually impact human life, right? And so in those cases, I think developing that sense of responsibility also drives you to come up with sort of strong solutions to things like data accuracy. I think this is sort of a kind of a term that I heard later in my life called zero defect, which is if your data or if your products can be zero defect, meaning if you can have as little sort of mistakes in them as possible. That's something that actually we thought about way back then in the early days. And that really ties to what we're trying to do today, where it's really harder to become zero defect. And yet the decisions that we're making every day are based on data that may actually be accurate, may be inaccurate. And that's a scary proposition.
Super interesting. I don't know what I was expecting as the answer, but that was a wonderful one. It makes perfect sense to me. So then after that, you studied mathematics and computer science at Stanford, and you worked as a management consultant at Bain, and then you held a number of senior roles in organizations, no doubt involved in data and analytics and using those data and analytics for commercial purposes within the organization. So feel free to fill us in on any major things from that giant period of your life. Distill it down to one really great point. But the place that I'm trying to get to is to understand what led you to founding your own company, to founding Monte Carlo and being the CEO of that company. How did that come about?
Yeah, I think Prior to Monte Carlo, I was at a company called Gainsight, which created the customer success category. And so I learned a few very important things. One, I learned about the importance. So one of the most important things that we did in creating the category was actually to make it quantitative and solidify what customer success means based on data. So in the past, customer success was something that was really often subjective. And, I would sort of buy your software because you bought my software and maybe I'm using it, maybe I'm not. And in today's world, it's like you are earning your customer's business every day. And in order to do that well, you actually need to use data about your customer. Then you need to understand, are they using your product? Are they not? Are they happy with it? How are they using your product? And so I was always sort of fascinated with how data can, improve our lives, improve business outcomes. And I just feel very fortunate to be during this time where there's such advances in data in general. And I think some of the things that led me to start this company is actually at Gainsight. I noticed sort of in working with hundreds of companies is that the biggest thing that folks sort of trip over and felt, including myself, was the ability to trust the data. So I remember we were trying to become very data driven as an organization, and we couldn't rely on the numbers that we were looking at. Like I was looking at a report and I was like, I don't even know if this is right or not. And if it's not right or wrong, if it's not right, then I might as well just go with my best guess. And in that case, like, why are we even collecting this data to begin with? And I remember my team spending so much time sort of asking these questions too. And I was like, why is this so hard? This should be easy. And if we want to become data driven, it's not going to get easier. And so, I think sort of wanting to really solve that pain. And, I ended up sort of speaking with lots of other companies outside of my work after Gainsight actually to understand, how are they addressing this? What are the main sort of root causes for why data goes down? And all these different questions that I really wanted to make sure, like, am I the only one who's struggling with this? When you start a company, you don't really know if you're solving something that someone else will care about. Right. And so I was curious, like, am I solving something that only I care about or other people do? And I was just thrilled to learn that it's something that lots of people care about and that it's unsolved. And so, I just couldn't imagine a world where there wouldn't be a solution to this. I was like, we're not going to become data driven if we don't solve this. So we better go solve this.
Cool. So what's up with the name? What's up with the name Monte Carlo? When I think of Monte Carlo, I think of like casinos. And this is kind of the opposite. You're like, you're trying to reduce risk. You're trying to increase data accuracy. It's like, you don't want to be taking any chances with your data.
Yeah, that's very true. So when we started the company, we were thinking about the name, and we actually didn't have a lot of time to decide because quite frankly, we had customers who wanted us to sign papers quickly and start working with them, and so. I opened my my stats book and was searching for names.
Markov chain Monte Carlo.
Exactly. That's right. So, Markov chain was a little bit too much for my taste. It was a candidate, but it couldn't make it work. And so that's where we landed. And also my co-founder, Lior, is a big fan of Formula One. So you'll often see him with a Formula One hat. So we just felt like it's right. And we sort of figured in good old startup fashion that we'll solve it later if it becomes a problem.
Nice. That sounds great. That's a really good and really honest explanation. You'd think that over the years, you'd come up with like a really great story. But just honestly, we're just looking for one really quickly. Great. Well, it makes, it's memorable to me. I think it's a really great company name. So, all right. So you start the company. You quickly realize that, yes, there are other people out there who need this problem to be solved. How did you get some to pay? And specifically, so Ramesh Vakalagada, who's a senior research fellow at the Center for DNA Fingerprinting and Diagnostics, has asked this question of you. He wants to know how you landed your first few clients.
Great question. And I'll give you the honest answer here as well. So when we started the company, one of the things that can be a little bit confusing or misleading as a founder is you want to make sure that you're working on a problem that people actually care about and they're not just being nice to you. And oftentimes, if you ask people, hey, what do you think about my startup idea? If I come up to you, John, I'll be like, hey, I'm working on this new idea. What do you think? you might be like, oh my God, Barr, like that's such a great idea. I love it. Like just because you want to be nice to me, it's sort of human nature, right? But then when the time comes and you're like, okay, well, you pay for this. Are you actually going to pay? You're like, oh, so sorry. I have 10 other things that are more important, right?
Yeah. My favorite answer in those kinds of situations is like, I can see why your solution is great, but not for me.
That's right.
There's someone else out there who this is perfect for.
That's right. This is awesome. I love it. Just for my neighbor there.
Exactly.
Exactly. That's right. And so when you start a company, I was sort of faced with how do I find folks? How do I actually validate that? Right. I can't work with anyone who will give me sort of this is a great solution. I need to find out whether people actually care about this. And so I actually cold called people and I was like, is this a problem that you care about? And suppose I had this solution, would you want to use it? So people that I never spoke to, and that was the bar for whether this is an important enough problem. I was like, if people care enough about this pain point that they will talk to someone like me with no company at the time, no brand, nothing behind me, if this is important enough to them, they will engage. And indeed, that's what happened. The first 10 customers that we had, we did not know them before. We had no relationship with them. And so, the way that we did that was by making sure that this is a really important pain point to them, putting a product in their hands really quickly. So, we didn't develop product in the dark for years. We actually put something in the hands of customers very, very fast, within weeks. And then made sure that thing actually solved a real problem for them. And in that case, actually, they wanted to pay us. To be perfectly honest, I was shocked when they were like, hey, we want to pay for this. And I was like, what are you talking about? They're like, yeah, this is a great product and we should be paying for it. And that was a sign too, right? I was like, if someone wants to pay, this means that it's important enough.
That sounds really great. And it reminds me of the kinds of philosophies that you read about in a book like Lean Startup. You find people who are, on the cutting edge, who are looking for something new to solve a new problem. And you get it into their hands quickly and you get feedback quickly and you iterate from there. You don't worry about making the perfect product. You just get them something.
That's absolutely cool. Right. And I read at the time various books, and Y Combinator has a great blog with sort of things to do early on, unscalable things to do, which has been very helpful for me. There's a variety of resources that are incredibly helpful for early stage. I would say the other sort of thing that's really valuable is actually speaking to other founders who are, sort of a few years ahead of you. They typically have some great advice.
Nice. Yeah, that is great guidance and some great resources, which we'll have in the show notes. So another audience question, this one's from a machine learning engineer named Bernard, who's a repeat question asker here on the Super Data Science Show. I recognize his name. And Bernard is curious what the typical workday is like in a startup like yours. I guess it's interesting for him maybe what your workday is like, but I think also more generally, I'd love to know what it's like for a data scientist or a software developer in a company at kind of your stage solving your kind of problem.
Yeah, definitely. So I will say that at this stage, probably no 2 days are alike. So every day is really sort of different and changes. And also the company changes a lot. So, I was sort of encouraged the company to think through, the rate that we're growing, the company needs to be or the company sort of is growing intensely every week and every month. We've basically 10x the number of people that we had in the last year in the company.
Wow.
And that means that each and one of us has to also get better at our job every week, every quarter, every month. And so, the type of things that my job was when it was just me is very different than when we were few people and a few tens and a few hundreds, right? It'll be very different. And so one of the things that I talk a lot about my team is rewriting your own job description. And sometimes after 2 weeks or 3 months or 6 months or a year, you're suddenly in a place where the company needs something different from you. And so you actually need to write a new job description for yourself. And so I think maybe sort of the constant theme and what does a day-to-day like is a lot of adaptability to change. recognizing that you and the company and the landscape changes a lot. That's sort of the big core thing. There's two additional ones that I'll mention. The second is around the speed of change. So there's a value that we really reference a lot at Monte Carlo, which is measure in minutes, meaning sort of our, at our stage or level of impact is not kind of years or months, it's actually in minutes. And so we need to be thoughtful about how do we make every minute count. And the way to make every minute count is by making a customer impact really quickly, which is the third part. So we are extremely customer focused. I think a lot of that has to do with the fact, that I kind of like grew up in the customer success industry, if you will. And so I really think that fundamentally the most important thing that data organizations in particular, data scientists specifically, but also companies in general need to really focus on is being extremely customer driven. So for everything that we're doing, how is this impacting your customers today? And so if you're a data scientist at Monte Carlo or a software engineer, or if you're me, you're all doing the same thing, which is focusing on making our customers as happy as possible. We might be coding, we might be speaking to customers, we might be writing blogs, we might be doing a bunch of other stuff, but whatever it is, it ultimately all has to point towards making our customers extremely happy. That is everyone's job description, the first bullet line, now and forever.
Beautiful answer, Barr. And in the spirit of measuring in minutes and knowing that you have a hard stop coming up in a few of them, and need to jump off and get to another meeting and probably make a customer very happy, make some big impact for them. I have one last question here, which it's from Svetlana Hansen, and she's curious about how you address biases in data. And so I assume she's asking about kind of unwanted biases. So probably biases against particular sociodemographic groups, for example. And so we talked about this a little bit before the show. It sounds like in production, there isn't something in Monte Carlo that's a solution in that space, but it's something that you're curious about and maybe have future products in the works for.
Yeah, certainly. I think this is one of the top most important and most interesting problem for us to solve in data, and has impact in what Monte Carlo does, but also everywhere else, right? In politics, in pandemics, you name it, right? Data is now driving all of that. And so our ability to make decisions and think about bias is incredibly important. I will say that there's a book that Daniel Kahneman just released recently called Noise, which actually addresses or talks a little bit about noise and bias. That actually, I just started reading it, but it seems great and I highly recommend it. I think it fundamentally speaks to how, surprisingly, how often we make wrong decisions based on wrong data due to noise and bias, and how way more prevalent it is, and discusses some of the aspects of that and some surprising new learnings that he found.
I haven't read Noise yet, but I read Daniel Kahneman's. I say Kahneman. You say Kahneman. You're probably right because he's Israeli, isn't he?
He is, I think, formerly Israeli, but I'm actually not sure what the exact pronunciation is.
I don't know. Anyway, somewhere in the middle.
Yeah.
But I've read. Oh my goodness, how am I?
Thinking Fast and Slow.
Thinking Fast and Slow. Yeah, exactly. I was stuck there in my System 1 and needing my System 2 to really kick in there. Where are you, System 2? I need you.
System 2 to the rescue.
Yeah, exactly. Well, in that case, you were to the rescue. So I absolutely love that book. Thinking Fast and Slow, it impacts how I act and how I try to think every day. And it's been such an important book in my life. So I'm not surprised to hear that Noise is also great. And I can't wait to check that out. So, Barr, I always end the show with a book recommendation, and you just segued right into it. So we saved you a couple of minutes right there. It's been so awesome having you on the show. I learned a ton in this episode, and I'm sure audience members did too. If they want to follow you and learn more, what should they do?
You can check out our blog, montecarlodata.com. We write pretty regularly about these topics and others, data mesh, data reliability, how to build a data team, what does a data product manager means, all those topics, stuff that we write a lot about. You're also welcome to reach out to me on LinkedIn, Barr Moses, if you'd like to connect directly. Super happy to chat about this stuff. It's one of the things that I'm most passionate about.
Nice. All right. Thank you so much, Barr. It's been wonderful having you on the show, and maybe we'll have you on again sometime soon.
Sounds great. Thanks so much for having me.
Barr is such a brilliant expert on data science and in particular on successfully building a data-focused startup. And Barr manages to effortlessly and clearly convey technical content in such a cool, smooth way. I really admire her style. In today's episode, Barr filled us in on how data meshes involve the central definition of a company-wide data standard that liberates anyone across the organization to create, store, and analyze data. She talked about monolithic versus distributed microservice-based software architectures, how data reliability is analogous to software service uptime, what a data product manager is, how 5 categories of data metrics enable us to solve the good pipeline's bad data problem, specifically freshness, volume, distribution, schema, and lineage. And Barr talked about how feedback via cold calls and getting products into customers' hands within weeks can greatly accelerate a startup's early success. As always, you can get all the show notes, including the transcript for this episode, the video recording, any materials mentioned on the show, and the URLs for Barr's LinkedIn profile, as well as my own social media profiles at superdatascience.com/499. That's superdatascience.com/499. If you enjoyed this episode, I'd of course greatly appreciate it if you left a review on your favorite podcasting app or on the Super Data Science YouTube channel, where we have a video version of this episode. To let me know your thoughts on the episode directly, please do feel welcome to add me on LinkedIn or Twitter and then tag me in a post to let me know your thoughts on this episode. Your feedback is invaluable for figuring out what topics we should cover next. All right, thanks to Ivana, Jaime, Mario, and JP on the Super Data Science team for managing and producing another stellar episode for us today. Keep on rocking it out there, folks, and I'm looking forward to enjoying another round of the Super Data Science podcast with you very soon.